So let's look at installing network load balancing. Now, network load balancing is a feature that works off of ports, TCP or UDP ports. We're going to configure network load balancing and port rules here in a few minutes. Key thing though, it is a feature, not a role. So a feature is going to support a role. So in our scenario, we're going to install network load balancing, and we're going to create port rules that are going to manage traffic for HTTP. So what we would do is we would create a web server, and then we would install network load balancing as a feature to support that to load balance across multiple web servers. That's going to be the other thing. Network load balancing balances traffic. It does provide some redundancy, but that's not its primary purpose in life. That's kind of almost accidental. Its purpose is to balance traffic across multiple servers. So let's start by installing the network load balancing feature. So we're going to add roles and features. Next. All right, it's not a server role, so we're not going to find it here. We've got to go to the next screen and find our features, and then we're going to find network load balancing. Select that, add the load balancing management tool, click next, and install. While that is installing, a couple of things we got to talk about. Network load balancing. Typically, if you're running a role and then you're load balancing, you want that role to basically be the only thing that this server is doing. You don't want it to be doing multiple other things as well. So you're going to want that. The other thing is this is good for content that's relatively static and not necessarily content that's dynamic and constantly changing. So network load balancing, probably not good for database servers, works pretty good for web servers. So in our scenario, we're doing a web server, so you're going to want to make sure that the website files are identical on both servers, or if they're using shared storage, that both of them are able to read from those files simultaneously. All right, our installation is completed, so we're going to click close, and then we're going to go to our tools and network load balancing. There we go, network load balancing manager to manage our load balancing cluster. So I'm going to right click, and if I had an existing cluster already that I wanted to manage, I'd click on connect to existing. I don't, so I'm going to create a new cluster. So the host that is going to be part of the cluster, I'm going to do 127.0.0.1. So I'm just going to loop back and look at my own. And I'm going to find my interface. And if I have more than one, it'll be listed here, and then I'll select which one is going to be the one that's going to be used by the cluster. And I'll click next. All right, priority. We're going to create port rules to handle traffic that's destined for the cluster. Priority has to do with anything that comes to the cluster that's not defined by a port rule. That would be handled in priority order. So the host with the lowest priority number is going to handle it. And you can have, this number can be 1 through 32. And so you can just say, if this is number 1, then it's going to handle that traffic. Unless it goes down, then number 2 will handle it, so on and so forth. Now, default state here. Do we want this started, stopped, or suspended when the system comes up? We want it to go ahead and be started. So let's click next. And then we're going to set a cluster IP address. Now, I've got my own IP address on this device. In fact, every device as part of my cluster is going to have its own IP address, but I'm also going to have a cluster address, and that's going to be the one that the rest of the world is going to connect to. So when they connect to the cluster, they need to connect to this address. And I'm going to make that address 10.1.1.5. My own is 10.1.1.10, so I need to make sure that I don't pick something that is going to create a conflict with anything else on my network. So this has to be part of your addressing scheme. So I'm going to add that in and click next. Now, cluster parameters. We have set an IP address, we've set a subnet mask. We also need to set an internet name. So I'm going to say cluster.mylastname.local. And then we're going to have the MAC address that's going to be associated with this cluster. Now, next thing is operation mode. Unicast, multicast, or IGMP multicast. Multicast is actually a little more efficient. So I'm going to choose multicast. In fact, if you're doing Hyper-V, you kind of have to. If you're doing this in Hyper-V. Couple of big things here. Multicast is a little more efficient, but if you're doing this across a across to a router, your router has to be configured to allow multicast traffic. The other thing that we've got to be aware of is that if we're doing unicast, we really have to have more than one network card in order for this to work. Since I only have one in this, it's Hyper-V, I'm limited to that single one at the moment. I haven't added another virtual network adapter. We're going to do multicast. All right, port rules. Now, by default, we have one port rule that's defined, and this is where you get to go look up port numbers again. So we happen to be doing a cluster for web hosting. I know that runs on TCP port 80. So I have this default rule, all cluster IP addresses from 0 through port number 0 through 65,535, all ports, for both TCP and or TCP and UDP. We're going to do multiple affinities or multiple host and single affinity. I'm going to edit that, and then let's take a little closer look at this. So I can select specific cluster IP addresses that I want this rule to apply to. I'm going to go ahead and leave it as all. Now, I'm going to disable port 0 through 79. There we go. Because I only want this thing to handle TCP port 80. So I'm going to disable all of this, and I'm going to select disable port range and hit OK. So that's going to eliminate all of that. Now I'm going to add port 80, and I want just port 80 to port 80, and I want it to be TCP. Now, filtering mode. I can set it for multiple hosts, so multiple hosts can respond to this, only a single host, or we can disable this range. I want multiple hosts to be able to respond to web requests, so I'm going to click multiple hosts. Now, affinity, I've got none, single, or network. So affinity has to do with if you get multiple requests from the same client. So affinity 1 means if the client makes multiple requests of the cluster, with no affinity, each individual request could be handled by a separate server or separate node in the cluster. Single affinity means if I get multiple requests from the same device, they all have to be handled by the same cluster host or cluster node. Network affinity means if I get a request from a single host, then anything else from that network, and we're assuming a /24 network here, right? So anything else, any other client with an IP address where the first three octets match that one, go to the same server. Now I'm going to go ahead and set this as single. By the way, anything that requires session establishment is going to work much better with single or network affinity than no affinity. So I'm going to go ahead and leave it as single, and I'm going to hit OK. Now, that gives me port 80 is now active for TCP using multiple affinity. We're doing equal cost load, or multiple hosts, equal cost load balancing, single affinity. I want to disable everything above port 80 as well. So I'm going to add a new one. I'm going to add port 81 through 65,535, both, and I want to disable this port range. So now the only thing that should be handling would be web traffic. And I'm going to click Finish. Okay, at this point, it is up. Now, I can right-click on this cluster, and I can add another host to a cluster. And so I'd do the add host, and I'd pick the IP address that I want, as long as both of them are configured right. So the cluster isn't going to verify that your configuration is correct, right? The cluster is going to see if anything comes into this IP address we define for the cluster, 10.1.1.5. With port 80, I'm going to send it to one of these two devices, or however many that I have. So I add another host to cluster. I make sure that everything's configured on those hosts. The operating systems need to be pretty much the same. They need to be at the same patch level. I mean, really, you need these things. Hardware-wise doesn't matter, but software-wise, you need these things to be pretty much identical. I can also delete the cluster here. Let me click on cluster properties, though, because this is where we're going to do some of our configuration. So here are cluster IP addresses, and I can add, edit, remove my cluster parameters, including the internet name and the operation mode, and then port rules. I can add, edit, or remove port rules. And then just click on whichever one I want, edit it, and away we go. Okay, so that's how I can configure my cluster as a whole. I can also work with my individual hosts, and you'll see my host here has that little green box in the background. All right, that means it's online. So I can right-click and remove the host from the cluster. I can see the port rules that are applied to it. I can set host properties. So This is the host itself, which IP addresses are dedicated to it, what the priority is, what the state is, and then I can review some of the cluster configurations as well. I can also look at host status, and that's going to tell me the current status of this, summary converged, which means, yay, everything's good. The other thing I can do is I can control the host. And I've got 5 options here: start, stop, drain, stop, suspend, resume. All right, start and stop, pretty straightforward. If I stop a cluster host, then it will stop responding to anything that comes to that network load balancing cluster. Start it, I restart it. Suspend, pause it, resume it. Drain stop is the interesting one. So if I do a stop, and you'll see this happen immediately, that goes red, which means this host is done. It's not doing anything for the cluster anymore. Not responding to any requests for the cluster. That happens immediately, which means if there were active sessions on this, they immediately get terminated. Well, that's not always very good. Sometimes we want to bring it down, but we want to bring it down a little more slowly. And so that's what drain stop is. What drain stop does is the host will no longer accept new client connections. However, it will keep serving its existing client connections until those clients terminate. And then your clients who are connected to this host don't get suddenly terminated. They can break off contact whenever they're ready, and then we just don't add anything more to it. And so we let all of the connections kind of drain out, and then we stop it. So that's what drain stop is. You will do that sometimes if you are going to take a host down to do some maintenance on the host, something like that. Drain stop, way cleaner than using just a straight stop. Stop is there if you need to do it and you need to do it now. And if a client loses something, well, oops, we didn't really have many choices in that. So there is a real quick introduction to configuring and installing network load balancing clusters.